Hello, welcome to your new class. Today we will learn about services. As I explained to you earlier, services are one of the four app components. So far we have studied activities in detail. Today we will discuss and study services. So let's get started. So a service is an application component that can perform long-running operations in the background and does not provide a user interface. So this is the major difference between a service and an activity. Activity provides a user interface, service doesn't provide a user interface. So services are useful, for example, when you want to download a file. Now, just like activities, another application component can start a service. And once a service is started, it will continue to run in the background even if the user switches to another application. This is another difference than the activity. Now, additionally, on top, a component can bind to a service to interact with it and even perform inter-process communication. We will discuss this in detail in some another class. But here the service, very briefly let's discuss. Here the service sort of is providing us a inter-process communication. That is making two processes talk to each other. So you bind to a service and then you can interact with the service. So for example, a service might handle network transactions, play music, perform file IO, or interact with a content provider all from the background. So services are very useful component for an Android applications, and today we are going to understand how do they work. Now there are primarily two types of service forms. So the first is that what we call as started. So a service is started when an application component such as an activity or another service starts it by calling start service. So once started, a service can run in the background indefinitely even if the component that started it is destroyed. That is, the life cycle of the service is different than the life cycle of the component. If you remember earlier when we were discussing fragment and activities, fragment depended on activity. So a fragment was very much decided by the activity, but services, this is not the case. Even though a service is started by an application component, the service may live even beyond than what the component that started it. So usually a started service performs a single operation and does not return a result to the caller. The single operation could be downloading or uploading a file. It could be playing the music. Now, ideally, you should design your service in such a way that once the operation is complete, the service should stop itself. We will discuss it very soon. The another form of service is what we call a service is bound. A service is bound when an application component binds to it by calling a special method named as bind service. Now, as discussed earlier, a bound service offers a client-server interface that allows components to interact with the service, send requests, get results, and even do so across processes with inter-process communication. So a bound service sort of provides you a nice set of services around the IPC. And a bound service, unlike the started service, runs only as long as another application component is bound to it. So if there is no application component bound to it, the service is destroyed. So this is different than the started service where it is not destroyed even when the component which started it has been destroyed. And bound service, the moment no other application component is bound, the service also gets destroyed. and multiple components can bind to the service at once. However, at least one component must be bounded to the service in order for the service to live. So as soon as there is no component bound to a service, the service is destroyed. Now let's discuss something more about services. So any application component can use the service, just as we discussed earlier. In previous lectures, we have also told what are the application components. These are primarily activities, services, background receivers, and content providers. So any application component can use the service even from a separate application similar to an activity, in the same way that any component can use an activity. And in fact, the method of starting a service is also very similar to the method that we learned when we wanted to start an activity. That is, we can start a service by an intent. So we can use an intent and we can start a service. Now, you can declare a service as private in the manifest file, and you can block access from other applications. So this is one difference between services and applications. In applications also, you can try to control it by using intent filters, etc. But service you can declare as private. So a service runs in the main thread of its hosting process, and the service does not create its own thread and does not run in a separate process. So what does it mean? So very soon in the next lecture, we will learn more about processes and threads. But if you go back to your operating system knowledge, then usually there is a process running on its own in the main thread, and unless you start a separate thread, everything runs in the main thread. Now this makes the execution more predictable and more understandable. However, if there is a long running task, then the especially for the UI type of work, the UI suffers. So similarly, when we are creating a service here, the service will run in the main thread of its hosting process and does not create its own thread. So this is something to remember. So if your service is going to do any CPU intensive work or blocking operation, you should create a new thread within the service to do that work. If you don't do it, service will keep running in the main thread, and then the main thread will get occupied in the activities of the service, and that may hurt the experience of the user, and that may hurt the performance of your application. Now let's get started with the basics of the service. So what do we need to do if we want to, let's say, create a service? So we learned how to create an activity, we learned how to create a fragment. Now we are trying to learn how to create a service. So creating a service is also very easy. You create a subclass of service. You override some callback methods, just like in case of activities and fragments. And then for the bound services only, you also provide a mechanism for components to bind to the service. So by doing these three operations, or mainly two operations, you can start a service. Now let's have a look at the service callback methods. And we will only look at the important callback methods. So there are four important callback methods for a service: on start command, on bind, on create, and on destroy. Now let's get started with the first method, the on start command. Now the system calls this method when another component, such as an activity, requests that the service be started by calling start service. Now please try to pause yourself here and think that what happens in case of activity, and you will find some similarities. Now once this method executes, the service is started and can run in the background indefinitely. So if you are implementing this method, it becomes your responsibility, that is the responsibility of the developer, to stop the service when the work is done by either calling stop self or by calling stop service. Now, if you only want to provide binding and not a started service, as we discussed earlier, you don't need to implement this method. Now, let's move on to the second method. The second important method is the onBind method. So the system calls this method when another component wants to bind with the service, such as to perform RPC by calling bind service. Now, in your implementation of this method, you must provide an interface that clients use to communicate with the service by returning an iBinder. And you must also implement this method, but if you don't want to allow binding, then you should return null. So we always implement on bind. If you want a bounded service, we return the correct type, otherwise we just return the null. Then there is this onCreate method, which is kind of similar to the to our earlier studied onCreate methods. Now the system calls this method when the service is first created. So this is same as what was the case with the activity. To perform one-time setup procedures. And before the system calls either on start command or on bind. So the on create is the first method that is called by the system when the service is first created. Now, if the service is already running, that is some other app component has started the service, then obviously this method is not called. The fourth method is the onDestroy method. The system calls this method when the service is no longer used and is being destroyed. So your service should implement to clean up any resources such as threads, listeners, receivers, etc. when you get the call to the onDestroy. Now, if a component has started a service by calling start service, then the service remains running until it stops itself with either stop self or another component stops it by calling stop services. And if a component calls bind service to create the service, then the service runs only as long as the component is bound to it or any component is bound to it. So once the service is unbound from all clients, then the system destroys it. Now, Android system itself will force stop a service only when memory is low and it must recover system resources for the activity that has user focus. Now, try to remember here, the activity has a user interface, service doesn't have a user interface. So, if the memory is low and the system must recover system resources, the Android system will force stop and service in order to keep alive an activity. Now, if the service is bound to an activity that has user focus, then obviously it is less likely to be killed. And if the service is declared to run in the foreground, then it will almost never be killed. So we will very soon come on the foreground services, but you can understand that if a service is bound to an activity that has the focus, there is no advantage of killing it. Otherwise, if the service was started and is long running, then the system will lower its position in the list of background tasks over time. That is kind of reduce the priority, and the service will become highly susceptible to killing. That is, if the system needs resources, it will kill the service. So it is your responsibility that if your service is started, then you must design it to gracefully handle restarts by the system. Now, if the system kills your service, it restarts it as soon as resources becomes available again. Uh, there is a slight catch here because it also depends on the value you return from on start command, but we will discuss it very soon. Now, this was all about basics of service, and as you may have guessed, the services have many things in common with activity as far as the concepts are concerned. And the major difference between service and activity is that while the activity has a user interface, the service does not have a user interface. Now let us see that how can we work with services, that is, how do we write programs that uses services. So the first step, just like last time, for activities, you declare a service in the manifest. Here's an example of a very basic manifest file. It starts, there's an application tag, and inside that application tag, I have a service with the name of example service. That's it. My manifest will include, as we know, all the app components. So my manifest will also include the services that my application has. Now, in order to create a started service, as we discussed, is the one that another component starts by calling a start service. And this call to the start service results in a call to the service on start command. In case of a started service, the service must stop itself when its job is done by calling stop self, or another component can stop it by calling stop services. Now, for creating a started service, traditionally there are two classes you can extend to create a started service. The first class is the service class itself, which is the base class for all services. And when you extend this class, it is important that you create a new thread in which to do all the service work. So as I explained earlier, that service runs in the main thread, and if the service is doing CPU intensive work, then it affects the UI. So when you extend this service class, you create a new thread in which to do all the service work. Now the second method is to by extending intent service. So intent service is a subclass of service that uses a worker thread to handle all start requests one at a time. So the service was the base class and the intent service is a subclass. In service, it was in the main thread. In intent service, it is using a worker thread. Now, the intent service is the best option if you don't require your service to handle multiple requests simultaneously. Means your service is of the type where you know that there will not be a scenario when you will have multiple requests simultaneously. In that case, intent service is much better and easier way to do this. So all you need to do will be to implement the onHandle intent, which receives the intent for each start request, so you can do the background work. Now, let us look at how do we first create a service by extending the intent service class. This is an easier method, very easy to understand, very easy to implement. So, what do we do? Create a default worker thread that executes all intents delivered to onStart command, separate from your application's main thread. Another thing that it does is to create a work queue that passes one intent at a time to your onHandle intent implementation so that you do not have to worry about the multi-threading. So intent service is already doing a lot for you. And then it stops the service after all start requests have been handled, so you will not have to call stop self. Intent service also provides default implementation of onBind that returns null. If you remember, there was a condition with onBind that we must override it even if we have to return null. It looks like that intent service already does that. And then intent service also provides a default implementation of onStart command that sends the intent to the work queue. and then to your on handled intent implementation. Here's a simple example of the intent service extension to create a service. Let me, let me start from the very beginning. So there is a public class hello intent service extends intent service. We require few things. Number one is that we do require a constructor, and this constructor must call the super constructor with a name for the worker thread. So here it is. We have a constructor which is calling the super constructor. Now the intent service calls this method from the default worker thread with the intent that started the service, and when this method the on handle intent returns, intent service stops the service as appropriate. So the second step that we have to do is to override the on handle intent. We do not do much. We take the on handle intent, and inside that, actually speaking, this is where you will be doing the actual work. But because we are only demonstrating the concept, we are just saying, hey, go and sleep for 5 seconds, and that's it. So that's the work that we are doing using this thread. Now let's come to the second method of extending the service class instead of extending the intent. Now, when we have such a simple method of extending intent service, why would we like to extend the service class itself? So here is one reason given to you. If you require your service to perform multi-threading, okay, instead of passing start request through a work queue that we were doing, then you need to extend the service class to handle each intent. So let's look at an example. This is a rather long example. So yes, here we are trying to create a service by extending the base class service. I will only go through some of the major topics. So for example, here we have to create a handler that receives message from the thread. We'll come to it later. So let's see our first override. Our first override method is the handle message method, and here again, just to demonstrate, we are only sleeping for 5 seconds, and then we stop the self service. But more importantly, let's look at some of the other methods. Especially I am interested in the on create method. So the on create method is what starts up the thread running the service. So we are creating a separate thread because the service normally runs in the main thread, which we don't want to block, and that is we don't want to run the service in the main thread, and we want to make it a backend thread so that we can even do CPU intensive work. So it is still fine. We create a backend thread, handler thread type, and then we start the thread. And then we get the handler threads looper and use it for our handler. This is the same looper service handler that we had described earlier. And then let's look at some other method that we have overridden. Another method is this on start command method, where we are just displaying a toast. So yes, we do the toast, and we know which request we are stopping when we finish the job. And if we get killed, we are returning something. So here the most important thing to look at is that what are we returning from on start command. So we return an int, and this int has takes three values. One of the values is start sticky, and very soon we will see that what other two values are and what is the meaning of this method. And then there is just on bind, because we are just returning null, and then there's on destroy, where again we are just displaying toast. So let's go back to this method on start command and the int value that it is returning, because that is the important bit here. So it can return one of the three things. The first is start non-sticky. So this means that if the system kills this service after on start command, there is no need to recreate the service unless there are pending intents to deliver. The second is the start sticky, and which means that if the system kills the service after on start command, recreate the service and call on start command, but do not redeliver the last intent. Instead, the system calls on the on system command with a null intent. And then the third is the start redeliver intent, in which if the system kills the service after on start command, it returns, recreate the service and call on start command with the last intent. That is, it sort of repeats everything. Now, looking at the code, you saw that how much easier it was by extending just intent service compared to by extending the service itself. Now, let us see that how do we start a service. So starting a service is same as starting an activity. In fact, it is very much the same thing. So you create an intent, and from that intent, then after you call the start service, and then you pass the intent into it. So the start service method will return immediately, and the Android system will call the service on start command method. Now, if the service is not already running, the system first calls on create and then calls on start command. Now, once a service is started, the system does not stop or destroy the service unless it must recover system memory and the service continues to run. I am emphasizing it again and again because this is very important point to remember, that once you start a service doesn't stop by itself, and you must make the provision so that the service stops either by calling stop self from the service itself or another component calling stop by calling stop service. So once requested to stop with stop self or stop service, the system destroys the service as soon as possible. Now, so far we were talking about creating a started service. Now let's also discuss a little bit about creating a bound service. As we saw earlier, bound service was mainly for IPC communication and to bound other components to a service. Now, a bound service is one that allows application component to bind to it by calling bind service in order to create a long-standing connection. And one should create a bound service only when you want to interact with the service from activities and other components in your application, or to expose some of your application's functionality to other applications through IPC. Now, in order to create a bound service, you must implement the onBind callback method. Remember, in other cases we return a null, but here we will not return a null. This method should return an iBinder that defines the interface for communication with the service. So what does it mean by interface for communication with the service? As you know that this service needs to talk with other components. If they need to talk, then there must be an interface over which they talk and they can understand. And this is the interface that we are talking about. The other application component can then call bind service to retrieve the interface and begin calling methods on the service. So the bound service is pretty much like an IPC, where you get the interface, you find out how to interact with the service, and then you start interacting with the service. Now, service can send notification to the user in two ways. Number one is a toast notification, as we saw earlier in our math quiz example. And number two, the status bar notification. So if you have been using Android phone, you can see that on a status bar, some of the messages come, which you see. So this is one of the method by which a service can talk to the user. So if there was a service which is for downloading a file, after it has downloaded, it can possibly set a status bar notification. Now, earlier we said that services run without a user interface in the background. You can actually run a service in the foreground as well. So a foreground service is a service that is considered to be something the user is actively aware of. For example, I want to play the music. So I would like the user to be actively aware of this. And because the foreground service is something our user is actively aware of, it is definitely therefore not a candidate for the system to kill when the system is low on memory. Now, a foreground service must provide a notification for the status bar, which is placed under the ongoing heading, which means that the notification cannot be dismissed until the service is either stopped or removed from the foreground. Now, let us see a program example of running a service in the foreground. So, here is a notification that must come, and the most important thing to observe here is this method: start foreground ongoing notification id notification. So notification is the way to indicate the user, and start foreground is the way to start the service. Now let us look at the life cycle of a service. The life cycle of a service is normally much simpler than that of an activity. As you saw, that activity life cycle is depends very much on how user is interacting with the user interface that is provided by activity. And because service doesn't provide a user interface, the life cycle of a service becomes much easier. So the service life cycle, that is when it is created to when it is destroyed, can follow two different paths depending on the form of the service. So if it is a started service, then it is created when another component calls start service, and then it runs indefinitely till either it calls stop self or another component calls stop service. When the service is stopped, the system destroys it. On the other hand, the bound service is created when another component calls bind service, and the client then communicates with the service through an iBinder interface. The client can close the connection by calling unbind services, and though multiple clients can bind to the same service, when all of them unbind, the service is destroyed by the system itself. Now, let us look at the simple lifecycle callback methods. This is a very simple example, only giving you a very small idea of how these methods look like. So there's on create, on start command, on bind, unbind, rebind, destroy. And as we did in the activity, it is a good practice that when you write your first service program, just override them, put a log message here so that you know when these methods are being called. Here is a graphical representation of these methods. As you see, that call to start service comes, on create comes. So here is when the service is running, that is after the on start command, and when the service is stopped by itself for a client, for on bind again after the on bind command, and when the last on unbind has been called. Then service call on destroy is followed by services shutdown. So this was all about services, which is one of the most important app component besides activities. I have given you small program snippets in this video. I would soon be uploading a program running a service, but before that, you can actually use these snippets and create your own program where you create a service and maybe don't do much but just override all the callback methods and put a log messages and then just try to see the life cycle of a service. Thank you.